Hello, welcome to another video. In this video I'll be going through mock set 4 paper 2. This is for the EDEXCEL higher tier. The paper and the mark scheme will be in the description if you want those. But let's just get straight into the questions. So question 1 says divide 7,560 into the ratio 4 to 5. Well, how many parts do we have? We have 9 parts. So we need to divide 7,560 by 9 and then multiply it by 4 and 5. Or you could just multiply this by 4 over 9. However you want to do it. So I'll just get a calculator. 7,560 multiplied by 4 over 9 for my first number, 3,360, and then by 5 over 9 for the second number. Multiplied by 5 over 9, 4,200. Maybe it's a good idea to show some working out just in case. Alright, so that was question 1 for 2 marks. Question 2 says here is a Venn diagram. List the numbers of set X. So here's X. What's in that circle? Well, it's 1, 3, 5 and 15 for 1 mark. Part 2 says X intersect Y, which means everything in X and Y. So that's going to be in this middle part here, so that's just 3. Part 3 says list the members of X union Z, which means everything in X and in Z. So that's going to be 1, 3, 5, 9, 15 and 21. And part B says a number is chosen at random from the universal set E. Find the probability that this number is Y union Z. Okay, so how many numbers do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers. How many in Y union Z? Well, that's everything in Y or in Z. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the probability of getting Y union Z is going to be 8 out of 11 for 2 marks. That was question 2 for 5 marks. Question 3 says ABC is a right angled triangle. Calculate the length of BC. Give your answer correct to 1 decimal place. This is finding a leg of a right angled triangle with Pythagoras' theorem. Remember, Pythagoras' theorem says this leg squared plus this leg squared equals the hypotenuse squared. So you can reverse that to find the leg, the length of a leg. So if I call this x, then x squared is going to equal the hypotenuse squared, take the other leg squared, so 6.7 squared. So x equals the square root of that, and we can put that straight into a calculator. Get your calculator out, put the square root. 16 squared, take 6.7 squared, bracket, and that gives me 14.529, and it says to 1 decimal place, so that's going to be 14.5 to 1 decimal place. That was for 3 marks. Question 4 part A says write 1.04 times 10 to the power 5 as an ordinary number. So this is in standard form. How do we convert from standard form? Just think of this number as 1 with 5 zeros. That's 100,000. So this is 1.04 times 100,000. Or what's 1 times 100,000? That's 100,000. So 1.04 would be 104,000. Another way to do it is to take this number and move the decimal place 5 places to the right. So 1, 2, 3, 4, 5. And wherever you have gaps, you put zeros. So that's going to be 104,000. Part B says write 0.06 in standard form. So to be in standard form, you need the first number to be between 1 and 9. So this one will be 6 times something. How do we figure out what the power of 10 is? Well, how many times have I moved that decimal place to the right? Twice, so this is going to be to the power of -2. Or you could think of this as 6 divided by 100. There's a few ways to think about standard form, but 6 times 10 to the power of -2 is the answer there. Part C says 4.62 times 10 to the 8 tins of beans were sold last year. These tins of beans cost a total of 300.3 million. Work out the average cost per tin of beans. Okay, so we're looking for the cost per tin. So the cost is 300 million 300,000. And the number of bins is going to be 462 million. So if you expand that out to an ordinary number, you get 462 million. Now, if you have standard form in your calculator, you could put that in. I'm just going to put that in as this, but feel free to do it however you like if you think it's more efficient doing it the other way. So 300,000 divided by 462 million, 6 zeros, and we get 0.65. So 0.65 pounds is the average cost per tin. Make sure you don't do it the other way around. So that would be tins per pound, how many tins you get per pound. So each tin costs 65 pence. So that was question 4 for 4 marks. Question 5 says Becky buys a new car for £25,000. The value of this car will depreciate by 20% at the end of the first year and then by 12% at the end of every year after the first year. Work out the value of the car at the end of 3 years. Okay, so it decreases by 20% in the first year. One way to decrease something by 20% is multiply it by 80% or 0.8. And if we do that in a calculator, 25,000 multiplied by 0.8, 20,000. So that's after the first year. Then it decreases by 12%. That's the same as multiplying by 88% or 0.88. So if we put that in, take that answer, multiply it by 0.88, we get 17,000, that's meant to be an equal sign, 17,600, and then take that answer after 2 years and multiply it by 0.88 again, because it says 12% at the end of every year after the first year. So take that answer, multiply it by 0.88, and we get 15,488. Sorry, just double check, yep. So my final answer there is £15,488. That was question 5 for 3 marks. Question 6 says the diagram shows a shape made from a trapezium, ABCD, and a semicircle with diameter DC. DC equals 8 centimeters. The shape has area 64 centimeters squared. The height of the trapezium is 5 centimeters. Work out the length of AB. Give your answer correct to 1 decimal place. Okay, so the area of this entire shape is 64 centimeters squared. Now, the formula for the area of a trapezium is going to help us here. So the area of a trapezium is the top plus the bottom lengths multiplied by h divided by 2, or you might know that as h divided by 2 multiplied by a plus b. Just the same thing, just writing it different ways. And now that's going to help us find AB, but we don't know the area of the trapezium yet. The first thing we have to do is work out the area of the semicircle, take that away from 64, and then we'll know the area of the trapezium. So firstly, we need to work out the area of the semicircle, which is going to be the area of a circle, pi r squared, divided by 2. The radius here is half of 8, so the radius is actually 4, not 8. I could see some people making mistakes by using 8 instead of 4. So the radius squared will be 16 divided by 2. This is going to be 8 pi. If we put that into a calculator, we could actually do 64 take 8 pi, 8, and you should have a pi on your calculator. It'll be probably in little yellow writing, so you have to do second function pi, and we get 38.867. So that's the area of the trapezium, because I've done the total area, take the area of the semicircle. So I should show that as well. So the area of the trapezium is going to be 64 take 8 pi, which I got to be 867, etc. So now we can say all of this equals the area of the trapezium, which is 38.867. So let's substitute some things here. We know the height, we know the base, so we have a plus 8 multiplied by 5 divided by 2 equals 38.867. Multiply that by 2, divide by 5. So I'll just show what I'm doing here. So to get a by itself, I need to multiply this by 2, divide by 5, and then to get rid of that plus 8, I need to subtract it. So all of this, take 8. And by the way, don't do that on your exam paper, I'm just being lazy. So I'm going to put all of that into my calculator in one go. So I'm taking this answer, multiplying it by 2, dividing by 5, and then subtracting 8. I might need some brackets in there as well. And I get 7.5469. 7.5469. And it says round to 1 decimal place. So to 1 decimal place, this is going to be 7.5 centimeters. That was question 6 for 5 marks. Question 7 says, on Monday, 4 bricklayers took 3 hours to lay a total of 4,200 bricks. On Tuesday, there were only 2 bricklayers. Work out how many hours it will take the 2 bricklayers to lay a total of 3,150 bricks. Okay, from this information, we need to work out the rate of bricklaying for 1 bricklayer. Let's firstly write down the rate for 4 bricklayers. They had a rate of 4,200 per 3 hours. What is that per 1 hour? Well, 42 divided by 3, that's 14. So this is going to be 1,400 bricks per hour. So therefore, 1 bricklayer, based on that information, will be this rate divided by 4, because this was the rate for 4 bricklayers. So 1 bricklayer will be 1,400 divided by 4. 14 divided by 4, that's 3.5. So this is going to be 350 per hour. So then we can work out the rate for 2 bricklayers. That'll be 350 times 2. So 350 times 2 is going to be 700 per hour. So how long would it take them to lay 3,150 bricks? That number divided by the rate. So 3,150 divided by 700. And I might put that into the calculator. So 3,150 divided by 700. That gives me 4.5. So 4.5 hours is my final answer. That was question 7 for 3 marks. Question 8 says Simon invested an amount of money in a savings account at 0.5% per annum compound interest. At the end of 3 years, the amount of money in the savings account was 12,180.90. Work out how much money Simon invested in the savings account. You must show you're working. Okay, the compound interest formula is going to help us here. And the compound interest formula says the final amount, the total amount, the principal plus the interest equals the principal multiplied by 1 plus the rate as a decimal to the power of the number of years, or t for time. Okay, so here the rate as a decimal is going to be 0.005. That's the same as 0.5%, so just divide by 100. The time is 3, and we're looking for the principal that he started with, so how much money he invested in the beginning, which is P. A, the final amount is 12,180.9, so I can put all of these in and then solve for P. So this is going to be 12,180.9 equals P bracket 1.005, so I've just added those together, to the power of 3. Therefore, P equals 12,180.9 divided by 1.005 to the power of 3. Then I just need to put that into my calculator, and that gives me an answer of 11,999.99852. And I'm actually going to round that to 12,000. And the mark scheme also says 12,000. So I'm not sure why that is. It doesn't say anything about rounding off in the answer, but there you go. 12,000 for the answer there, and that was question 8 for 3 marks. Question 9 starts with a diagram, and it says PR and PS are 2 sides of a square. PS and PT are 2 sides of a regular pentagon. PR and PT are 2 sides of a regular polygon with n sides. Work out the value of n. You must show you're working. Okay, so this is going to involve the formula for the angles in a polygon. Well, we know the angles in a square, they're 90 degrees, so this is 90 in here. We can figure out the angles in a pentagon, and that's going to allow us to figure out this angle here, RPT, and then that's going to allow us to find n. Okay, so if you don't know what the angles in a pentagon are, you can work them out. So let's start with that. So angles in a pentagon equals, and this is the formula to find the angle. It's the number of sides, take 2 times 180 divided by n. And if you haven't seen that formula before, I've made a video on that and how it's derived. So we just need to input 5 for n here, so it's going to be 3 times 180 divided by 5. 540 divided by 5, that's going to be 108 degrees. So the angle in the pentagon here is 108 degrees. Therefore, this angle in here is going to be 360 take 108 take 90, or 360 take 198. That gives you 162. So this will be 162 degrees in here. Because angles around a point add up to 360, I might just write that reasoning down. It's always a good idea to add as much detail as you can to the questions, keeping in mind the time limit. So this is 162. Therefore, we can say for this unknown polygon, n take 2 multiplied by 180 divided by n equals 162 degrees. So I've just reversed that angles in a polygon formula, and now I'm going to solve for n. So I could start by multiplying by n on the right hand side. So n take 2 multiplied by 180 equals 162n, and maybe expand out the brackets, so I get 180n take 360 equals 162n, and then maybe add 360 to the right hand side and take 162n from the left hand side. So on the right I'll have 360, 180 take 162, that's 18n. So then n is going to equal 360 divided by 18. I might just do that on a calculator, and I get 20. So this polygon has 20 sides. That was question 9 for 4 marks. Question 10 says solve the simultaneous equations. Okay, so one way to solve simultaneous equations is the elimination method, and this involves adding or subtracting the equations in order to get rid of one of the variables. Now to do that, one of the coefficients of the variables needs to be equal. So I might try to make the y coefficients equal. So if I call this equation 1 and equation 2, if I multiply equation 1 by 2, the whole thing, and equation 2 by 3, that will give me a coefficient of y of 6. So let's take equation 1 and multiply that by 2. So it's still going to be the same equation. I've just multiplied everything by 2. So 2x times 2, that's 4x. 3y times 2 is 6y. 6 times 2 is 12. And for equation 2, I'm multiplying that by 3. And if you're not quite following, it'll make sense in a minute why I'm doing this. So 7x times 3, that's 21x. Minus 2y times 3, that's minus 6y. And 1 times 3 is just 3. Now I have a plus 6y and a minus. If I add these equations together, that will cancel the y variable from those equations. I'll just be left with an x, and then I'll be able to solve for x. Okay, so what I'm going to do is add 1 to 2. 4x plus 21x, that's 25x. Plus 6y plus minus 6y, that's going to be 0. They cancel each other out. And then 12 plus 3 is 15. Then I could divide by 5, so this is going to be 5x equals 3. So therefore x equals 3 on 5. Okay, I've solved for x. Now I need to put this into one of the original equations to solve for y. I'm going to pick the first one, so substitute into equation 1. Therefore I'll have 2 times 3 on 5 plus 3y equals 6. 2 times 3 on 5, that's 6 on 5. Plus 3y equals 6. Therefore 3y equals 6 take 6 on 5. So that's like 6 take 1 and 1/5. So 6 on 5 equals 1 and 1/5. Take that away, I get 4 and 4/5, right? So 6 take 1 is 5, take 1/5, I'll have 4/5 left. So all up, I'll have 4 and 4/5. Another way to write this is 4 times 5 is 20 plus 4. This equals 24 on 5. So 3y is going to equal 24 on 5. And then divide that by 3. So y equals 24 on 5 divided by 3, or the same thing as multiplying by a third. If I multiply this by a third, I could cancel a 3 from the 24 and the 3. So that cancels out just to 1. This cancels to 8. So therefore, y equals 8 on 5. Okay, so my final answer there is x equals 3 on 5 and y equals 8 on 5. And that was question 10 for 4 marks. Question 11 says the incomplete table and the incomplete box plot give information about the number of lorries using a bridge each day last January. Here's the table and the box plot, and part A says use the information in the table to complete the box plot. Okay, so in a box plot we have a minimum, lower quartile, median, upper quartile and maximum. So we need to write them in the table, and they've given us the upper quartile and the greatest number. So we can start with that to complete the box plot. So the upper quartile is 280. This grid is going up by tens. So this would be 250. Therefore, this would be 280. So draw your upper quartile, and that joins up with the rest of the box to finish that box off. Then we need to draw the maximum out at 405. So that's going to be halfway between these two lines. Make sure you line it up with the rest of the box. Draw a straight line in there and then join it up with a whisker. Okay, so that should be your box plot finished. And then we need to fill in the least number. So this is going to be down here at the minimum, that's 20. The lower quartile is here, that's 170. And the median is 200. Okay, so that's part A and part A number 2 for 2 marks. Part B says the box plot below gives information about the number of lorries using the bridge each day last February. Compare the distribution of the number of lorries using the bridge last January and the distribution of the number of lorries using the bridge last February. Okay, so this is February. We have a median at 250, and for January the median was 200. So that's the first thing I'd comment on. So in January the median equals 200. In February the median equals 250. So on average, more lorries use the bridge in February. It's 2 marks, so I might find one other thing to comment on. So here the interquartile range is from 220 to what? To 280. So for February, the interquartile range is 60. And in January, the interquartile range is 280 take 170. So that's going to be 110. So January interquartile range equals 110. What does that tell us about the lorries on the bridge? Well, I guess there was less of a spread, so more consistently, more lorries were passing over the bridge. So there's less variation in February. To be honest, I'm not really sure what that means for lorries driving over a bridge, but I think if you comment on the average for the median, and on average more lorries use the bridge in February, then I think that should be good enough for the 2 marks. So all up, question 11 was 4 marks. Question 12 says A, B, C, D, E, F, G, H is a cuboid. Angle EDH equals 64 degrees, angle ACD equals 28 degrees, and EH equals 15 centimeters. Work out the size of angle AHD, give your answer correct to 1 decimal place. Okay, so they've labeled this side 15 centimeters. Angle EDH is in here. So this bottom right angle triangle, this is 90 degrees because it's a cuboid. So that's 64 degrees. Angle ACD, which is this back triangle on the back of the cuboid, that's 28. And we're looking for AHD, which is the diagonal of the cuboid in here. So you really have to try to think 3D here and try to imagine where this angle is, and we're trying to find that one in here. So let's call that theta. All right, so I think what we're going to need is 2 sides of this triangle ADH. To find those, I'll find DH using this right angle triangle, and I'll find AD using the ACD triangle. Because they're both right angle triangles, so I can use right angle trigonometry to find those sides, and then use right angle trigonometry to find theta. Okay, so let's start off by finding this hypotenuse. Now I know that the sine of an angle, sine of some angle equals the opposite side over the hypotenuse. So I have this angle, so therefore sine of 64 equals the opposite side, which is 15, divided by the hypotenuse, which is DH. Okay, so that's going to give me the size of DH. So therefore DH equals 15 divided by sine of 64. Okay, so we can go ahead and put that into a calculator. 15 divided by the sine of 64 equals 16.689. 16.689 degrees. Make sure your calculator is in degrees and not radians, otherwise you'll get some weird answers. Okay, now we're looking for AD. We know this side is 15 centimeters as well because it's a cuboid. So the base length should be the same, and we need to use the tan ratio here because we're looking for the opposite side to the angle, and we have the adjacent side. So the tan of 28 is going to equal the opposite side divided by the adjacent side. So therefore AD will equal the tan of 28 multiplied by 15. And we can put that into a calculator as well. Tan of 28 multiplied by 15 equals 7.9756, 7.9756, etc. Okay, now we have AD and DH. We can find the angle theta. So tan of theta is going to be the opposite side, AD, divided by DH. So therefore theta will be the inverse tangent of those things. Okay, so let's go ahead and put this into a calculator. Inverse tangent of AD over DH. Now you could put these rounded off numbers in, or you could put the whole calculation in. I'm going to try to do that, but the rounded off numbers I'm sure would still give you an accurate enough answer. So this is going to be the inverse tangent of the tan of 28 multiplied by 15 on the top line. And then on the bottom line, I have 15 divided by the sine of 64. Enter, and we get an answer of 25.543 for theta. 25.543. And it says, give your answer correct to one decimal place. So my final answer there is 25.5 degrees. And that was question 12 for 4 marks. Question 13 says 6 to the power of minus 2, all to the power of w equals 6 to the power of 8. Find the value of w. So this can be written as 6 to the power of minus 2w equals 6 to the power of 8. When you expand those brackets out, you need to multiply the powers. So therefore, minus 2w equals 8. So therefore, w equals minus 4. Final answer for 1 mark. A to the power r all to the power 2 divided by a to the power t all to the power 3 can be written in the form a to the power of u. Find an expression for u in terms of r and t for part B. So when you have the same base number, you can subtract the powers. So this could be written as a to the power of 2r subtract 3t. So therefore u equals 2r minus 3t. Part C says, given that n to the power of 2 on 3 equals 8 and n is greater than 0, work out the value of n. Give your answer in the form a root b, where a and b are integers. Okay, so n to the power of 2 on 3 equals 8. You need to understand what this means. This can also be written as the cube root of n squared equals 8. Now actually another way of writing 8 is 2 cubed. The reason I'm doing that is because if we need our final answer in the form of a root b, it's probably going to involve simplifying a radical expression. So I think it's going to be easier if we have a base of 2 rather than a base of 8. Anyways, to get rid of this cubed root on the left hand side, I want to cube the right hand side. So this is going to be n squared equals 2 cubed cubed, which will be 2 to the power of 9. And then to get rid of this square on the left hand side, I'll square root the right hand side. Another way of writing that is 2 to the power of 9 on 2. Now 9 on 2, another way of writing 9 on 2 is 4.5. So another way of writing 2 to the power of 9 on 2 is 2 to the power of 4 multiplied by 2 to the power of a half. because when you have the same base numbers, you can add the indices. So 4 plus a half would be 4.5 or 9 on 2. And then this is going to equal 2 to the power of 4 is 16. 2 to the power of a half is the square root of 2. Then I have it in the form of a root b, where a is 16 and b is 2. So my final answer there is 16 root 2. Now there are other ways to get to that final point. There's also another possible answer to this question. So if you have a different method, but you still end up with a root b, then that's fine. But you do need to have some integer out the front of the square root. Okay, that was question 13 for a total of 5 marks. Question 14 says there are some flowers in a shop. Each flower is either red or yellow. Each flower is either a tulip or a rose. For these flowers, the number of tulips and the number of roses is 6 to 5. The number of red tulips and the number of yellow tulips is 3 to 4. Work out the proportion of the flowers that are red tulips. Okay, I want to rewrite these a bit simpler. So I've got tulips to roses, or T to R equals 6 to 5. And I have red tulips to yellow tulips equals 3 to 4. Now what I want is a ratio where I have the red tulips to the yellow tulips to the roses. To do that, I need this number to be a factor of 7 because I have 7 parts in this ratio. So this number at the moment is not a factor of 7, but if I multiply this whole ratio by 7, then this is going to clearly be a multiple of 7. So then this ratio becomes 6 times 7, that's 42. 5 times 7 is 35. And now this ratio needs to add up to 42. So if I multiply that by 6, it will add up to 42, and it's going to become 3 times 6 is 18. 4 times 6 is 24. So now I can split this tulips ratio into red tulips and yellow tulips. So this entire ratio of all of the flowers is going to be 18 to 24 to 35. And then I can write this as a proportion by taking those 18 red tulips and dividing them by the total number of parts in this ratio. So if I add these up, 35 plus 24, that's 59, plus 18, that's going to be 77. So the proportion of red tulips to the total number of flowers is going to be 18 on 77. And that was question 14 for 3 marks. Question 15 says Alison has some shapes. She has 14 red cubes and 10 red spheres. She has 12 black cubes and 8 black spheres. Alison is going to select 2 of these shapes. Of these 2 shapes, only one can be red, only one can be black, only one can be a cube, and only one can be a sphere. In how many ways can Alison select 2 shapes? Okay, so what are the possibilities here? There are 4 types of shapes: red cubes, red spheres, black cubes, and black spheres. And she can only have 1 red, 1 black, so 1 color of each and 1 type of shape of each. So she could have a red cube, and so there's the red and the cube. Then she could have a black sphere and black sphere. Or she could have a black cube and then a red sphere. Or she could pick a black sphere first, so that's another possibility. But then she would still have to pick a red cube second. And those 2 outcomes are actually the same here because Alison doesn't care which order she picks the cubes in or the shapes in. She only cares what the outcome is. So she just worries about what 2 shapes she has in her hand after she's done the 2 picks. So these outcomes are considered to be the same thing: a red cube and a black sphere, or a black sphere and a red cube. And also here we could have a red sphere and a black cube second. And again, Alison is going to consider those 2 things the same outcome. So really there's only 2 outcomes here. We could get a red cube and a black sphere in either order, or a black cube and a red sphere in either order. Okay, so what's the possibility of getting one of these? So we've got 14 red cubes, and we have how many black spheres? 8 black spheres. So to work out the probability of getting either of those, I need to do 14 multiplied by 8. 80 plus 32, that's going to be 112. And then I have 12 black cubes and 10 red spheres. So the probability of getting that is going to be 12 times 10, which is 120. So all up, we have total outcomes of 112 plus 120, which gives us a total of 232 outcomes in all. That was question 15 for 2 marks. Question 16 says the graph of y equals x squared is reflected in the line with the equation y equals x to give the curve C. Part A says sketch the graph of y equals x squared and the curve C, clearly label the graphs. So this is a quadratic, about the most standard quadratic you can get, and it looks like this with the axes of symmetry being the y-axis. So this is going to be a terrible sketch, but you should see me sketch these with either a whiteboard or pencil and paper. Pretty good with those, but on the computer it's a different story. So yep, that's pretty bad, but you get the idea. This is y equals x squared, something like that. Y equals x is a diagonal line through the origin at 45 degrees to both. So every point on that line, the x value equals the y value. And this is y equals x. And now we need to reflect this curve in that line. So one way to do it, if you don't know what it should look like, you could just look at a couple of points on this curve, reflect them in that line, and then you should get a good idea of what it should look like. So let's say there was a point here, I reflected it in this line y equals x, it would end up, say, out here somewhere. If I took a point here, reflected it in the line, it would be somewhere over here. What if I put this point, if I reflected this point here in the line, it would be about here. Then if I reflected this point over here, it would end up over here somewhere, approximately. Doesn't have to be exact, just so you get the general idea. What if I took a point here and reflected it? It would end up over here somewhere. And then one more, if I took that point and reflected it, it would end up about over here. So then if you just did that quickly, you see where the quadratic ends up. It's like a sideways quadratic with the x-axis actually being the axes of symmetry. So then you could sketch that in, going through the origin, and label that C. And hopefully yours looks much neater than that. Okay, that was part A for 3 marks. Part B says here are 7 graphs. Okay, graph A, graph B, etc. Complete the table below with the letters of the graphs that could represent each given equation. Okay, let's just look at them quickly. So this is like an exponential, some number, say 2 to the power x. This is like the inverse of that, so 1 on 2 to the power x. This is the straight line graph, so ax, some coefficient of x maybe, plus some other coefficient. This is actually the graph of the tangent function. This is a hyperbolic function, or 1 over x. And well, this doesn't have to be 1, but that would be an example of a graph like this. This is a cubic, so x cubed, and this is another cubic. And they can also have, you know, an x squared term and a final constant as well. Okay, so we need to find 3 to the power x. So that's going to be this positive exponential. So I've written 2x, but yep, it could also be 3 to the power x. So that's graph A. The tangent function, as I said, that's what that looks like. So that's graph D. The cubic, there's 2 graphs that could be cubics. We need to look for the intersection of the y-axis. So if x was 0 here, y would equal 2. On this graph, you can see if x was 0, y would be a negative number. So it must be graph G for the third one there. And y equals 3 on x, that's going to be this graph E, this hyperbolic function. And that was for 3 marks as well, and question 16 for a total of 6 marks. Question 17 says the number of moose in Alaska at the start of year n is P subscript n. The number of moose in Alaska at the start of the following year is given by P subscript n plus 1 equals 1.05 bracket P sub n minus G, where G is a constant. The beginning of 2015, there were 200,000 moose in Alaska. The beginning of 2016, there were 200,720 moose in Alaska. Work out how many moose there were in Alaska at the beginning of 2017. Okay, so these 2 equations are going to allow us to solve for G. because they tell us G is a constant, and we'll need that in order to be able to find the number of moose in 2017. So the first thing we could do is use this information to find G. So we could say the number of moose in 2016, 200,720, equals 1.04 multiplied by the number of moose in 2015, 200,000, take G. All right, so once we've substituted those in, you can see we've only got one unknown, G, and we're going to be able to solve for that. So the first thing is we could divide by 1.04, 200,720 divided by 1.04. I get 193,000 equals 200,000 take G. And then therefore G must equal 7,000. 200,000 take 7,000 equals 193,000. So G equals 7,000. Now we have that constant, we can go ahead and find the number of moose in 2017. So P sub 2017 equals 1.04 multiplied by 200,720, the number of moose in 2016, the year before, take 7,000. And now all we need to do is solve that. So 1.04 bracket 200,720 take 7,000 equals 201,468.8. And now if we're talking about moose, we probably don't want that 0.8 of a moose, so we want to round that off. I would round it up to 469. So the number of moose at the start of 2015, my final answer there is going to be 201,469. And that was question 17 for 4 marks. Question 18 says, solve the inequality 2x squared plus x minus 3 is less than 0. Represent the solution set on the number line. And there's a number line down here. So firstly, I want to take this quadratic and factorize it as you would a normal quadratic. So this is going to be, well, 2x and x would be the first terms in the bracket. And then I need some coefficients that add up to 1 plus 1 for the middle term. So if I multiply 2x by 1, and then I have a 3 here, and I make that 2x a negative, and that 3x needs to be a positive. So 3x take 2x is going to be plus x, and then plus 3 multiplied by negative 1 is going to be negative 3. And now what I'm going to do is just assume this equals 0 in order to find the roots or the zeros of this quadratic. So this is going to be a quadratic. It's going to look something like this, and it's going to cut the y-axis at negative 3. Now I know it's up this way because the coefficient of x squared is a positive number. So anytime the quadratic has a coefficient of x squared to be positive, that means it's upwards, like a smiley face because it's positive. And then if that's a negative 2, it would be around the other way. So I know it looks something like this, and in order to find where it cuts the x-axis, I can make this quadratic equal to 0 and then find the values of x. So therefore, I can say that 2x plus 3 equals 0, or x minus 1 equals 0. Therefore, x would equal minus 3 on 2, or x equals 1. So that's where these roots are, these zeros, at minus 3 on 2 and 1. And then you can see just from the diagram that this graph is less than 0 in between those numbers. So in order to satisfy that inequality, x is going to be less than 1 and greater than negative 3 on 2. So that's that area in there. Now if I want to draw that on a number line, you need empty circles because it's not less than or equals to, it's just less than. So we need to draw an empty circle at 1 and then an empty circle at minus 1.5, the same as negative 3 on 2, and then join them up with a straight line. Okay, so that represents that interval, and then you're done. And that was question 18 for 4 marks. Question 19 says OAB is a triangle. Vector OA equals A, vector OB equals B. P is a point on AB such that AP to PB equals 3 to 2. So the ratio here is 3 to 2. Find OP in terms of A and B. Give your answer in its simplest form. Okay, so in order to find OP, which is this one, firstly I will need AP, the vector AP, or PB, either one. I'm going to find AP, but you could do it the other way. In order to find AP, I need AB. So that's the first thing I'm going to figure out. So AB could be written as, well, I'm trying to get from A to B, so I could go negative A plus B, or another way of writing that is B, the vector B, take A. And so if AB is B take A, then AP will be 3/5 of that. So AP is going to be 3/5 of B take A. And then OP, you can see, will be A plus AP. So OP is going to be A plus 3/5 B take A. All right, and then we just need to simplify that, and that will be our final answer. So expand these brackets out. 3/5 B take 3/5 A. A take 3/5 A. 1 take 3/5 is 2/5. So I'll be left with 2/5 A plus 3/5 B. Another way of writing that is 2A plus 3B on 5. And that's my final answer there. Not too bad for 3 marks. Question 20 gives us a function, 1 take x over 1 plus x. And part A says show that f of x equals x. So this is a composite function. This means that we need to take this whole function and input it into itself. So wherever we have an x, we need to put this whole thing in for x. So f of x is going to look like 1 take. When we get to that x, we need to put the whole thing in. So 1 take x over 1 plus x divided by 1 plus x over 1 take x over 1 plus x. So hopefully you can see there, I've just written out f of x, but every time I saw an x, I took this whole thing and plopped it straight in there. And now I need to simplify this messy looking expression. The first thing I do is find a common denominator, so multiply 1 by 1 plus x. So this is going to be 1 plus x over 1 plus x. Take 1 take x over 1 plus x. And then this one's going to be 1 plus x over 1 plus x plus 1 take x over 1 plus x. Then we have common denominators, so we can add or subtract the numerators. Now this one, remember that negative needs to be expanded to both terms there. So that numerator in the top fraction is going to become 1 plus x, take 1 plus x. A negative multiplied by a negative is a positive, all over 1 plus x divided by 1 plus x plus 1 take x divided by 1 plus x. Okay, then simplify this. So on the top numerator, this is going to be 1 take 1. They will cancel out. I'll be left with 2x there. And on this one, x take x, they'll cancel out, and I'll just be left with 2 there. So my next line will be 2x over 1 plus x divided by 2 over 1 plus x. Okay, and anytime you have a fraction with a fraction in the numerator and denominator, if they have the same denominators, you can cancel them out. So you can just think of that as flipping and multiplying. Say if you had 2 on 5 divided by 3 on 5, what would you do with that? You would say this is 2 on 5 multiplied by 5 on 3. And what would you do next? Well, you'd look at those 5s, you'd cancel them out. So when you have the same denominator, you can just cancel those. So then I'm left with 2x on 2. The 2's cancel, so I just end up with x. So we've shown that the composite function f of x equals x. Part B says hence write down f inverse x. So here you kind of need to understand what an inverse function is. So an inverse function says if x is the output, what was the input? So that's what an inverse function is really asking. If I get this x as an output, what have I put into that function? So hence, meaning is your answer to part A. So let's look at part A. When I inputted f of x into f of x, the output was x. So if x is the output, what was the input? The input was f of x, was this function here. So f inverse x is going to be the function we started with, f of x. So therefore I can say f inverse x equals 1 take x over 1 plus x. So a bit of a mind bender, that question, but hopefully that's making sense what an inverse function actually is. I have a video on composite and inverse functions if you're still feeling not too confident with that, so check that out if you want to. But that was question 20 for 4 marks. Question 21 says there are only red counters, yellow counters, and blue counters in a bag. Kevin takes at random a counter from the bag. He puts the counter back in the bag. Lethna takes at random a counter from the bag. She puts the counter back in the bag. The probability that both counters are red or that both counters are yellow is 13 over 36. The probability that the first counter is red and the second counter is not red is a quarter. Seb takes at random a counter from the bag. Work out the probability that Seb takes a yellow counter. You must show all your working. Okay, quite a lot of information there. We have red counters, yellow counters, and blue counters. We've had 2 picks with replacement. That means the order doesn't matter. So the probability of, say, a red and the yellow is going to be the same as the probability of a yellow then a red, because all of the counters are getting put back in the bag. So let's write down this information a bit more concisely. We've got the probability of a red and then a red, or a yellow and then a yellow, equal to 13 on 36. And then we have the probability of a red and then a blue, or a red then a yellow, equal to 1/4. So it says the second counter is not red. So when it has that or, it means those 2 probabilities added together. So we could have had a red and a red, or a yellow and yellow. Those 2 probabilities added together equals 13 on 36. Same for a quarter. It's not the quarter being the chance of each one happening, it's the quarter is the chance of both happening added together. And then in the question, it's asking for the probability of a yellow counter. So we don't actually have to worry about how many counters are in the bag. We don't have to take that into consideration. We only have to worry about the probabilities. So I'm going to introduce some variables here. So I'm going to let the probability of red equal R, the probability of yellow equal Y, and the probability of blue equal B, just to make it a little bit shorter to write. Now I'm going to write this equation again, just using those variables. So this is going to be RB plus RY equals a quarter, because when you say or in probabilities, you have to add those things together. When you're saying and, you multiply them. So R and B is R times B. Okay, so that's my first equation I've started with. So I might factorize that to begin with. So this is R bracket B plus Y equals a quarter. Now there is one other thing I know about probabilities. I know that all of these probabilities added together must equal 1. So R plus Y plus B equals 1. Now I want to substitute something into some of these equations to either end up with simultaneous equations or to try to solve them for one variable. So what I might do is try to substitute either for Y or B here. So I might try B. So let's say B equals 1 take R take Y. So I just subtracted those variables from the right hand side. So if I take that equation, substitute it into this equation I have over here. So let's call this equation 1 and equation 2. So if I substitute 1 into 2, where the B is here, I'm going to put all of this. So this is going to be R bracket 1 take R take Y plus Y equals a quarter. Now what happens here is that negative Y plus Y, they will cancel out. So I'll just be left with 1 take r in the brackets. Okay, so this is going to be r multiplied by 1 take r equals a quarter. Then expand those brackets out. R take r squared equals a quarter. And now I have an equation I can actually solve for r. And once I have r, I should be able to solve for y. Okay, so this is going to be quadratic. If I add everything to the right hand side, I'll end up with r squared, or subtract that r, take r plus a quarter equals 0. And now I need to factorize this. What are 2 factors of a quarter that add up to -1? Well, a half times a half is a quarter. And then if both of those are negatives, they will add up to -1. So the first term will be r, then my other terms will be -1/2 and -1/2. If you expand those brackets out again, you'll get r squared take r plus a quarter. Therefore, there's only one possible value for r from this. R must equal a half. In order to get 0 there, r must be a half. And now I know the probability of picking a red counter is a half. Now I'm going to take this other equation I started with here, probability of a red and a red or a yellow and a yellow equaling 13/36, and substitute in the probability for r, and I should be able to solve for y. So another way of writing this is r squared plus y squared equals 13/36. So r was a half, so this is going to be a quarter, plus y squared equals 13/36. Therefore, y squared equals 13/36 take a quarter. So what would that be? 13/36 take a quarter. Well, if I multiplied this by 9, that would be 9/36. 13 take 9 is 4. 4/36 can be simplified to 1/9. So 13/36 take a quarter is 1/9. Therefore, y equals the square root of 1/9, which is 1/3. And because we're talking about probabilities, we don't have to consider the negative. Remember, when you take a square root, you need to think it's a plus and a minus. But in this case, we only have to worry about the positive value. So the probability of a yellow is going to be 1/3 for a final answer there. And that was question 21 for 5 marks, and that's the end of the paper. I hope you found that useful. If you did, please leave a like, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.